If this video is blurred on your device, make sure you increase your YouTube resolution power so that you have a clearer version of the video. A sequence UN is recursively defined by U0 equal to 1, U1 equal to 8, and UN plus 1 equal to 5, UN plus 6, UN minus 1 for all n greater or equal to 0. No, I think this is for all n greater or equal to 1. Anyways, show that for all n greater or equal to 0, UN plus 1 minus 6 UN is 2 times negative 1 to the power n. UN is greater or equal to 1 and UN is monotonic increasing. Alright, so let's start with the first question where I'm going to think of 2 different methods, even 3 different methods even, or depends on you, but let me just do 2 methods because the video is going to be lengthy if I'm doing 3 methods. So I'm going to do 2 methods. First method is actually to find UN, okay? So in my first method, I'm going to find UN. So I start with my recursive definition, okay? So this, I'll bring everything to the right hand, to the left hand side. I'm going to have UN plus 1 minus 5 UN minus 6 UN minus 1 equal to 0. Okay, now next thing I do is that I identify this like kind of a second order differential equation. This is a second order recurrence relation because the difference between the highest subscript is the difference between the highest subscript and the lowest subscript is 2. So this is kind of a second, this is kind of a, yes, I can say a second order recurrence relation. So you can just kind of think about a second order differential equation. Okay, so let's get the homogeneous equation. So homogeneous equation is something like, it's going to be r squared minus 5r minus 6 equal to 0. We solve for r. Think factors of minus 6, that when we add, we have minus 5 multiply, we have minus 6. I think we can go with 6 and minus 1. No, minus 1, minus 6 and 1. So this is going to be r minus 6 into r plus 1 equal to 0, which means we have 2 values of r, which are those values. We have r equal to minus 1, r equal to 6. Now my solution will be un equal to a times negative 1 to the n plus b times 6 to the n. Okay, b times 6 to the n. Then we now use the initial conditions to find the values of the constants a and b. So u0 is equal to 1. It means that 1 is equal to, replace n with 0, you just have here 1 and you also have here 1. So at the end of the day, 1 is equal to a plus b, equation 1. Now u1 is equal to 8. What does this mean? This means that 8 is equal to, replace n with 1, you're going to have negative a plus 6b, equation 2. Now solve the 2 equations simultaneously for the values of a and b. Start by adding equation 1 plus equation 2. What do we have? Left hand side is 9 equal to a plus minus a 0, 1 plus 6 is 7, so 7b, which means that b is equal to 9 divided by 7. Okay, then what will be the value of a? A will be equal to 1 minus b, which is 1 minus 9 over 7, which should give us negative 2 over 7. Okay, so therefore my sequence un is equal to, what is a? Negative 2 over 7 times negative 1 to the power n plus 9 over 7 times 6 raised to the power n. So this is actually my sequence. Okay, that is my sequence. Okay, now let me now start manipulating. Let us take un plus 1 minus 6 un. So having un to be this, what is un plus 1? un plus 1 will be equal to negative 2 over 7 times negative 1 raised to the power n plus 1, which is the same as negative 1 to the power n times negative 1. So we can just remove the negative here and remove the negative here, okay? Then when we come here, we have plus 9 over 7 times 6 to the power n plus 1, which is just 6 to the n times 6. 9 over 7 times 6. But I think 9 times 6 is 9 times 5 is 45. 45 plus 9 is 50. 45 and 9 should be 54. Okay, so this is what I have. Okay, now what about 6un? So 6un is equal to 6 times everything here. Okay, so you're going to have negative 12 on 7 times negative 1 to the n, then plus 6 times that is 54. You have 54 on 7 times 6 raised to the power n. So if I now do un plus 1 minus 6un, what do I get? This cancels with this, and I have here 2 minus this gives me, since they have the same denominator, I will just add. It becomes 14 on 7, okay? And 14 on 7 is 2, so you have 2 times the common term, which is negative 1 raised to the power n as required. This method is long, but it works. So let's move to the next method, which is very short, okay? I've even thought about another method, so it means there are 4 different ways of solving this question. Now in the second method, let me just push everything down. Okay, so in the second method, it's kind of going to be a little bit pretty shorter. So in the second method, we realize that the left hand side, the right hand side is a geometric sequence, okay? Because you're seeing something like first term common ratio to the power n, so it's like a GP. So what I'm going to do is that I'm going to let Vn to be equal to I'm going to decrease the terms here by 1, so I'm going to have un minus 6un minus 1, so that Vn plus 1 just becomes what I have there on the right hand side. So Vn plus 1 becomes un plus 1 minus 6un. Okay, then I try to express Vn plus 1 in terms of Vn. So this means that Vn plus 1 will be equal to, what is un plus 1? This is un plus 1. Okay, so I have my un plus 1 there. Then I need to subtract 6un. Bringing like terms together, I have 5 minus 6 is negative un plus 6un minus 1, which, factorizing the negative sign, I'll be left with positive un minus 6un minus 1. But you come to notice that this is Vn, okay? So it therefore means that my Vn plus 1 is equal to negative Vn. If Vn plus 1 is negative Vn, it means that Vn plus 1 divided by Vn is equal to negative 1. That is a common ratio. Therefore, if I want to express a sequence Vn in terms of n, it will give me the first term. Now, in the first term, n cannot be 0, because if n is 0, we are going to have a u negative 1, which does not exist. So for my first term, n will be 1, okay? So I'm going to have v1 times negative 1 raised to the power n minus 1, like a r to the n minus 1. Now what is v1? v1 is gotten by replacing n with 1. You're going to have u1 minus 6u0. What is u1? u1 is 8. What is u0? u0 is 1. So 6u0 will just be 6, and 8 minus 6 is 2. So you're going to have 2 times negative 1 raised to the power n minus 1. But you clearly see that we are actually looking for Vn plus 1, okay? Because if you compare this with my Vn plus 1, they are exactly the same. So since I have Vn already, to get Vn plus 1, I'll just increase n by 1, okay? So at the end of the day, you clearly see the proof. Therefore, in conclusion, Vn plus 1, which is actually equal to this quantity here, okay, will just be equal to 2 times negative 1 raised to the power n as required. Now, the next method that came to my mind is proof by induction, which is going to perfectly work, okay, but there is no time to do that. So I think this method is shorter than the first one, because the first one actually went right up to finding un before doing anything else. But anyways, both methods are still perfectly correct, depending on, so let me just call this one method 2, depending on how you see it. All right, we are moving to the next question. B, show that for all n greater or equal to 0, un is bigger or equal to 1. So the only thing coming to my mind here is proof by induction. So we are going to let P of n be the statement un is greater or equal to 1 for all n greater or equal to 0, okay? Now, base case here, we need to verify that the statement is true for the first two values of n, because we have two initial conditions, u0 and u1. So I'm going to verify that p0 is true and p1 is true. So verify that p0 and p1 are true. Okay, now it is very clear that 1 is bigger or equal to 1 and 8 is also bigger or equal to 1. Thus, I'm going to replace the 1 on this left hand side with the u0, because u0 was 1. So at the end of the day, u0 is bigger or equal to 1. I'm going to replace the 8 on the left hand side here with u1, okay, and u1 is bigger or equal to 1. Therefore, p0 and p1 are true, okay. Now next is what we call the induction hypothesis. Here we need to assume that pk minus 1 and pk are true. We are doing this because we have initially two initial conditions. So in my induction hypothesis, I don't just assume one, I assume both of them, okay. So what we are saying is that uk minus 1 is bigger or equal to 1 and uk itself is bigger or equal to 1. Okay, then induction step here, we need to prove using the assumption above. We need to prove that the statement pk plus 1 is true. That is, we need to prove that uk plus 1 is bigger or equal to 1. So I start by finding what is uk plus 1. Okay, so I come back to get uk plus 1 will be 5 uk plus 6 uk minus 1. That's uk plus 1. So uk plus 1 is equal to 5 uk plus 6 uk minus 1. Okay, now I know that uk minus 1 is bigger or equal to 1. So let me just write down my hypothesis. uk minus 1 is bigger or equal to 1, which means that I multiply both sides by 6. 6 uk minus 1 will be bigger or equal to 6. Now I also know that uk is bigger or equal to 1, okay, which means that I multiply both sides by 5. So 5 uk will be bigger or equal to 5. I will add the two inequalities, okay, because they are in positive intervals. I'm going to have, if I add the left hand side, I just have the sum of this, and if I add the right hand side, I just get 11. But the sum of the left hand side is just uk plus 1, okay. So at the end of the day, we have proven, therefore we have that uk plus 1 is greater or equal to 11. But since 11 is greater or equal to 1, it therefore means that uk plus 1 will be greater or equal to 1. So I think it's better to write implication here. So when we imply that uk plus 1 is greater or equal to 11, and we know that 11 is greater or equal to 1, we can conclude that uk plus 1 is greater or equal to 1. because if you're greater than 11, definitely you're greater than 1 because 11 is greater than 1. That is what we call transitivity. Okay, so that is it. Then we now draw a conclusion. Finally, show that un is monotonic increasing. So here we just have to show that un plus 1 minus un is greater or equal to 0. This is what we need to show. Or we show that un plus 1 divided by un is greater or equal to 1. So either we show the first one or the second one, depending on what is convenient for us to show. So let me see. If I'm doing the first one, if I'm doing the second one, un plus 1 over un, un plus 1. In fact, we have already shown that un is bigger or equal to 1. No, we can't. It means that un plus 1 is also bigger or equal to 1. So I cannot be dividing. No, it's not possible. I cannot be dividing. Let me check the first proof. In the first proof, we proved that un plus 1 minus un is equal to 2 times negative 1 to the n. Can it help us? If we divide all through by un, no, we are going to have a divided by un here on the right hand side, which will not really make sense. So what is coming to my mind now is just to use this my answer here. Okay, just to use this my answer of un. Okay, yes, that's what comes to my mind now. While solving, maybe something else can come. So having un to be this, okay, I think we also have un plus 1. This is un plus 1 directly. I'm just going to subtract directly and check if the result is positive and conclude from there. So this is un plus 1, okay. So this is un, and then this is un plus 1. So what we are going to do is that let us take un plus 1 minus un and see what we have. So un plus 1 minus un will be, I'll take this minus this, it becomes plus 2 and 2 gives us 4. So 4 on 7 times negative 1 raised to the power n. Now this minus this, 54 minus 9 is 45. So we have plus 45 on 7 times 6 raised to the power n. Now what is common between the two terms is 1 over 7. We are going to be left with 4 times negative 1 raised to the power n plus 45 times 6 raised to the power n. It's very clear from here because we know that 6 raised to the power n will always be bigger or equal to 4 times negative 1 raised to the power n. Okay, yes, it's very clear because negative 1 raised to the power n is fluctuating between negative 1 and 1. Okay, it's fluctuating between negative 1 and 1. So something fluctuating between negative 1 and 1 is going to be very clear that the biggest value here will be 4. Okay, because when n is even, negative 1 raised to the power n is 1 and everything is going to be 4. When n is odd, negative 1 to the power n is negative 1, and here we are going to have negative 4, sorry. So the biggest value of this guy is 4, but this guy has no big value because when n is 1, 2, 3, you see it is increasing. Therefore this guy will always be bigger or equal to this guy. They are going to be the same. If n is equal to 0, no, it does not work for n equal to 0. So let me just put 45 there so that we are very certain. Because when n is 0, so that for n equal to 0 it's going to work. Because if n is 0, the right hand side is 4 and the left hand side is 45, so it's perfect. So since this is bigger than this, okay, it therefore means that if I add this guy on both sides of the equation, okay, if I add plus 45 times 6 to the n, on the right hand side I'm going to add 45 times 6 to the n. Okay, yes, In fact, this whole quantity on this side is always positive. Yes, it's always positive from just this explanation. So the result is always positive, and we are proving what is required to be proven. But now, what if you didn't have this UN? If maybe you use the first method I used, you realize that you're not going to have UN, which means here you need to find UN, which is a little bit lengthy. So let's try to take an alternative. I don't want to go through induction again because it might be lengthy. So let me try to look for an alternative. I think let's find a way of using the first proof. Okay, let me just copy it and paste down there. Let us see if it's going to be helpful in any way. So this is our first proof. Okay, so having this as a first proof, let us see. Remember, we need to do UN plus 1 minus UN. It has to be positive. Yes, it has to be positive for all n greater or equal to 0. So instead here we have UN plus 1 minus 6 UN. Okay, we have UN plus 1 minus 6 UN. So let me see if we could extract a UN from here. We'll be left with minus 5 UN, which goes to the right hand side to become 5 UN plus this. Okay, so that if I subtract back the 5 UN, I'll have minus 6 UN. So all we are left to do now is to verify if this part is positive. Let us see, can it be positive? Can it be positive? Let us see, UN is bigger or equal to 1. Okay. In fact, let us just try to allow it the initial statement. Now let us divide all through by UN. Okay, if we divide all through by UN, we are going to have UN. We are going to have here UN plus 1. Okay, divided by UN, then minus 6 equal to 2 times negative 1 to the n divided by UN. I've just divided all through by UN. Now I'm going to add 6 on both sides. It wipes from the left hand side and then moves to the right hand side to put 6 plus. Okay, voila. So I'm trying to show that it is greater or equal to 1. Okay, now let's focus on this part. We already have a 6 here. Okay, now let us look at this part. Okay, let's look at this part. Now for this part, we know that 2 times negative 1 raised to the power n will actually be between 2 and negative 2. Why am I saying so? I'm saying so because this negative 1 raised to the power n has only 2 values. If it is not negative 1, it is 1. Okay, because it is just fluctuating between negative 1 and 1 depending on if n is odd or is even. Therefore, if I'm multiplying it by 2, it should be fluctuating between negative 2 and 2. Okay, so if I divide all through by UN, I'm going to divide all through by UN. I'll divide all through by UN, and I'll divide all through by UN. Okay, this is what I have. Okay, now we are going to add 6 on all the sides. So I'm going to put 6 here, I'm going to put 6 here, and I'm going to put 6 here. Now I will focus on the part where I have greater or equal to. So I'm going to forget about this less than or equal to here. Let me focus on greater or equal to, because if this man is less than this man, because this man at the center is just equal to my UN plus 1 over UN. Okay, so let me just write this as, okay, UN plus 1 over UN is greater or equal to 6 minus 2 over UN. Okay, now for this answer to be bigger than 1, this 6 minus this, in fact this guy has to be bigger than 1. Not necessarily, but anyways, I know fully well that we have already proven that UN is bigger or equal to 1. okay, un is bigger or equal to 1, which means that 1 over un will be less than or equal to 1. Okay, 1 over un will be less than or equal to 1. Multiplying both sides by 2, 2 over un will be less than or equal to 2. So it means that everything here is less than or equal to 2. You see, now if everything here is less than or equal to 2, let's multiply both sides by negative. It therefore means that negative 2 over un will be greater or equal to negative 2, because inequality sign has to reverse since I'm multiplying both sides by negative. Then we are going to add 6 on both sides. So you are going to have 6 minus 2 on un greater or equal to 6 minus 2, which is 4. So at the end of the day, we have seen that un plus 1 divided by un is bigger or equal to 4. Okay, and since 4 is bigger or equal to 1, it therefore means that un plus 1 minus un is bigger, un plus 1 divided by un is bigger or equal to 1, which we needed, because if I cross multiply, un is positive since it was bigger than 1. If I cross multiply, I'll just have something like un plus 1 is bigger or equal to un, and if I subtract un on both sides, I will have un plus 1 minus un bigger or equal to un minus un, which is 0. Hence, we have proven. So there are many ways to go about it. This is just one of the ways I have seen that we can go about it to analyze it. Somebody could still go by mathematical induction, no problem. Okay, you can still use mathematical induction to do it. But I'll just stop here for now. See you guys in the next video, and thank you for watching.